To solve problem number 8 from the PSC2 review, you need to think back to the angle bisector opposite side conjecture. And what that says is that in any triangle, when you throw in an angle bisector, which this clearly is because you can see that those two angles are the same, since AD is an angle bisector, it chops this third side so that x is to y as z is to, x is to w as z is to y. So you can write a ratio that looks like this. W over x equals y over z. You could turn it. You could say that these two sides have the same ratio as these two pieces made by the angle bisector. So let's now, when we look at a sample problem, in this sample problem, I would set up x is to 8, and I would compare it to 5 is to 6. You do a little fancy cross multiplying here, and you can solve for x and get an answer. Now, this problem is similar. So now when we look at number 8, we know that we have to find some part of that third side to be able to solve for x. And one thing I do know is that if this is a right triangle, I know that I can take 5 squared plus b squared equals 13 squared, and that would give me that entire side here. This is 169. I'm going to subtract 25. That'll still give me b squared. So if I take the square root of that, that gives me b equals the square root of 144, meaning I know that this side from here to here is 12. So let's just, for the moment, put a y here. I can write an equation that says x plus y equals 12. Excuse me, that should say equals. I'm going to erase that to make that look like a better equals. So if I want to solve for y, I would subtract x from both sides. That leaves me with y equals 12 subtract x. So I can erase y and replace it with 12 subtract x. Now I can write a proportion. I'm going to say 5 is to 13 as x is to 12 minus x. Don't forget to use your distributive property when you cross multiply. Don't forget to, oops, that didn't work very well. Let's try that again. This is going to be 60 subtract 5x equals 13x. Add 5x to both sides, divide by the coefficient, and that will give you x.